Hi everyone, my name is Austin Brown, and I am going to be doing a critique of the scoping analysis on the seroprevalence of COVID-19 in Europe. This was a paper published in BMJ Open in September of 2020. It's a open access journal with a impact factor of 2.49. So a little bit of background. Uh, as we surveil for infections with COVID-19 throughout the pandemic, we're basically counting those who either were hospitalized with COVID or those who presented symptomatically. And we're not counting those who are asymptomatic because they don't know they're infected. And so we don't actually know the proportion of the population that is seropositive. In other words, they have antibodies to COVID-19. This is important because as we design public health interventions to curb the spread, uh, we tend to be heavy-handed with it because we don't know what proportion of the population is actually susceptible. And so we would like to know the seropositivity rate of um, the population in general in order to better tailor our public health interventions. The stated objective of this scoping review was to review SARS-CoV-2 prevalence studies that were carried out in Europe to better understand how those data could be used to inform public health strategies. So after their initial literature review, the authors identified 238 papers which looked at seroprevalence of COVID-19 in Europe, uh, and they used these inclusion criteria to narrow down which studies would be analyzed. So after applying their filter, the authors came up with 23 studies. 12 of these were generated from seroprevalence data in the general population, 8 from blood donor data, and 3 from different employers. To the right is their figure, which shows that they ended up with 18 studies, but that is incorrect. They ended up with 23. So in critiquing this review, I think it's pretty likely there was some bias and confounding. I don't think it's because the inclusion criteria weren't rigorous enough. Even narrowing it down to 23 papers, the quality of these papers were still debatable. Um, they were from different populations in different countries with different rates of reported infections. The quality of health systems in these countries were different, which is going to affect the rate of reporting in terms of symptomatic infections. Um, and then also, the papers were published between March and June, which some countries were just barely getting started. Some were already in the thick of it in terms of COVID-19 infections. And then lastly, they used different assays in different studies, so it's a little difficult to compare seroprevalence in that sense. So in their analysis, their primary outcome was measured as the ratio of reported infections through traditional means to reported infections through seropositivity. As you can see on the far right of the graph, they came up with a large range of values from 0.1 to 0.63. They spend a lot of time talking about this heterogeneity and why that might be. But I think more importantly, they didn't include measures of association, so we don't know the strength of association between the reported number of infections and the true seropositivity, so it allows for less generalizability. So in conclusion, due to the quality of the data, the authors were not able to state with any authority whether the number of reported infections was similar or dissimilar to the seropositivity within the population. But they were able to state that even with the most liberal estimates of seropositivity, at least between March and June of 2020, Europe was nowhere near the theorized 50 to 60% infection rate needed to curb transmission. So with that being said, they suggested that future public policy should be focused on an efficient rollout of an effective vaccine and not focused on reaching a rate of seropositivity as to reach herd immunity.